So the very important type of query is the Boolean query. It is probably not the most common and powerful method, but it's the simplest one to explain and a good one to start with. Boolean queries have a yes/no answer. They either match or don't match, and they can have these standard operators or and not. And here's an example of a particular Boolean query. We want Java and compilers in the document, and we want it to be either Unix or Linux, so we do not get documents about Windows, Java compiler. So this is a Boolean query, and the document is either relevant or irrelevant. And these are very fast operations. You have a very clean answer, 0 or not. And the disadvantage of this is that most languages do not speak Boolean. They speak a somewhat fuzzier thing. And also, we want to rank the relevance, and this will give us no relevance ranking at all. So any ranking has to be done outside this. And that's obviously critical because we know that from web queries that we return lots of documents. And so we have to have a ranking. So this is a very simple old information retrieval model. It's probably at the basis of all the other models, but this is not adequate for the modern. You will not be successful if you just use Boolean queries. Although many miserable systems I have to use, typically database systems, do insist that I do Boolean queries, even though I'd much rather do fuzzy queries, because I happen to know that there are all sorts of mistakes in the database that will be avoided with fuzzy queries. Plus, like I have an example where I have to use keywords to query a database of people, and unfortunately it doesn't tell me what keywords have been entered, and so I have to guess the keyword, and it's very frustrating. You keep on getting no answers for a particular query, and then you keyword query, and then you find a keyword that people have used, but that keyword may still not be the right keyword because it doesn't actually tell you which keywords exist. Very silly system. It's very successful, but it's silly. So here's some obvious example, 2 trivial documents, one with step and mankind and one with step and China. If you do a query step and mankind, you'll get document 1. If you do step or mankind, you will get document 1 or document 2. This points out that knots are very dangerous unless they are just making something more precise. So step but not China is a perfectly reasonable thing to say, but not China or not mankind is not such not a terribly useful concept because it's just it gives you too many results. Here we have yet more complicated constructs, which are probably mathematically allowed in Boolean queries. They're not very useful in my opinion, because most web queries and web documents are too wishy-washy to make these precise queries terribly valuable. In order to make progress, you need to form a so-called inverted index, which is a set of documents containing the term, which is then referenced to that term. That's called an inverted index, because documents have indices which tell you which words are in them, and an inverted index, the words tell you which documents have them. So that's why it's inverted. It's a map of words to documents, whereas indices are a map of documents to words. So this tells you what the inverted index for these examples here. We have 3 words, step, mankind, and China, and now step is mapped to 2 documents, mankind and China are each mapped to 1 document. So this allows us to, the inverted index allows us to answer very quickly the queries such as find all documents containing a given term. And then you can also combine indices to do to find unions and intersections, because obviously that corresponds to union and joining and intersecting the indices. And by converting queries into these standard forms, this gives you very, very quick answers. And this is sort of, a lot of this is the basis of why databases are so successful. And so the positive of all of this is a very simple paradigm. It's very well established. It's extremely easy to understand. And you can actually find all possible subsets of documents by a suitable query, but that's not actually terribly relevant because you can't actually make this query. It has a serious problem that these are the cons, the negatives. It's unordered. It is result size is whatever the result size is. Wishy-washy queries, similarity queries are not supported, and you get most of the relevant documents. You get most documents tend to be relevant because you're actually forcing certain words to appear in whatever documents return. But many relevant documents are not found because it doesn't do enough context searching to find things which may not have the exact words in them. I gave the example of semantic web. There are many documents that are on the semantic web which may not have the word semantic next to the word web. By the way, I've not described in this model how you do a search where you're looking for words to be next to each other. That is a refinement of these indices.